Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The question of the sun's possible role in triggering large earthquakes is a subject of growing scientific interest. For decades, some have noted apparent correlations between dramatic solar phenomena and seismic activity. Yet definitive scientific proof of a connection has remained elusive. Recently, the founder of Suspicious Observers, Ben Davidson, and colleagues published a landmark scientific paper revealing compelling statistical evidence of a role of solar activity in triggering large earthquakes. We asked Ben to give us the latest developments in his research, as well as a brief preview of his forthcoming talk at the Thunderbolts Conference, Elegant Simplicity, taking place June 17th to 19th in Phoenix, Arizona.
The foundations for investigating solar-triggered earthquakes were really a number of coincidences that really just stood out among what seemed like otherwise random data and suggested that solar phenomenon could trigger earthquakes. Now, to just look at sunspots, solar flares, or even its effects on Earth, you look at the geomagnetic index, how many geomagnetic storms is it producing, what level, things like that. Those are the main things people look at when they're looking at space weather and solar phenomena. And that's where a lot of the odd coincidences can be found. But that's not where that's not where you're going to find any patterns. It seems like sometimes you can use those things to predict earthquakes very well and correlate find a relationship between the Earth and the sun. And then other times it appears not to be the case. And so there's that question of why does there appear to be this on-off switch, sometimes weeks at a time, sometimes months at a time, on and then off, or, weeks on or off. And so we started to look beyond just solar flares and sunspots and things like that because we really see all of these things as symptoms really of something else that's happening. And that is a polar magnetic field cycle on the sun. This would be the solar polar fields that come out of the polar regions of the sun and wrap around towards the equator and pretty much encompass the entire solar system, coming out of the sun's poles just like Earth's magnetosphere comes out of Earth's poles. Well, this solar polar field cycle, which is the 11-year cycle, when it reverses is when we get sunspot maximum and all the flares and things like that. Well, not only are sunspots and solar flares and the resulting geomagnetic activity at Earth a function of this 11-year solar polar field cycle, but even things like the placement of coronal holes, sector boundaries in the heliospheric current sheet, basically the magnetic character of the solar wind, the size and the position of the solar prominences, often referred to as plasma filaments, all of these things are actually driven by this underlying 11-year solar polar field cycle that is often ascribed to being the 11-year sunspot cycle. But really, it's the magnetic fields on the sun that are really driving that. And when you look beyond the symptoms like sunspots and solar flares and geomagnetic activity to the underlying thing that is driving all of those things, the solar polar magnetic fields, you come to something that has never once been analyzed in terms of earthquakes until now. And when it is analyzed, you find that this is so perfect of a place to start this sort of new field of science that it really can't be ignored. Somewhere between 88 and 90% of the largest earthquakes in the world are shockingly close to these polar magnetic field cycle events. And so basically what I mean by that is during the 11 years that this cycle takes place, we get peaks in this magnetism, the high points in the magnetism about twice a year. They're about 6 months apart. We get reversals, positive to negative, negative to positive, about every 11 years. These things do not exactly happen all the time. They're spread far apart, and yet most of the major earthquakes on the list are within just a handful of days of these events that happen 6 months to years and years apart. And we have now completed our fourth study on this material. The first one was published last year. That was between myself, Dr. Kong Papuyen, who many in the EU community know already, and Dr. Chris Holloman, a statistics professor from the Ohio State University, who actually was able to take the pattern that we all were pretty sure we saw, translate it into mathematics, and actually prove that it was real. Well, since then, we've done subsequent analyses on the Chile 8.3 in September of 2015. We did a more longer term analysis of the solar polar fields just earlier this spring. And just in the last couple of days, the data has updated enough to show us that the first great earthquake of 2016, the magnitude 7.8 that struck off the coast of Indonesia on March 2nd, 2016, was indeed occurring at a negative peak in solar polar field magnetism. And it was a peak that actually had not been matched on the sun for 15 years. So which that's another way of saying that as the sun, presents these different levels of magnetism, the sun had not presented Earth with this level of magnetism since 2001, at least in terms of the negative polarity. And it does appear, now that we've gotten a little bit past that March 2nd event, that it was indeed a peak in the fields, because since then the total magnetic field strength of the sun has been weakening somewhat. So that was a long-term event and a short-term significant event as well. And it's looking like, based on the limited data we have thus far, this big one we just had in Ecuador about a week and a half ago, which was on the heels of that deadly earthquake in Japan. They happened just 24 hours apart. It's looking like we're going to have another peak there as well. So we also just had the word come in that that first paper, the foundational one with myself, Dr. Uyen, and Dr. Holloman, got its first citation. It was cited in a paper that was published late in 2015. Also talking about solar system phenomena and earthquakes. So it really sort of came out of the coincidences that seem to hint that the sun creates earthquakes, but guided by all of the very convincing research that says, hey, you can't use sunspots, you can't use solar flares, you can't use geomagnetic activity over long periods of time. Here's the data. Therefore, we have to conclude that there is no solar-induced earthquakes. Well, when you use that as your guide, you realize that all the things they're looking at are really just symptoms of the more driving, underlying force on the sun, you begin to realize how this could have been missed over the last few decades, and just how vital this can be when you see how well correlated the sun is with these large, oftentimes tsunami-inducing earthquakes. Once you've nailed down, using solar phenomena, the times when the Earth should get more active, you then need to be wondering where this activity is most likely to strike. Where's this earthquake going to happen? And the single most promising thing we've ever seen came out of the Demeter satellite. I believe it was a French satellite, and it was detecting ionospheric disruptions that seemed to occur before some of the largest earthquakes. Now, some scientists have written these off, others have been using them to try to create an earthquake forecasting system. The problem is that for all the times that this Demeter data, a couple, at least a dozen, for all the times it was used to publish papers on ionospheric disruptions before earthquakes, it was never once used to communicate such a disruption to the world as, hey, watch out, an earthquake may happen here. A lot of this stems out of what happened in Italy with the earthquake scientists. A lot of folks are worried about, liability with things like that. And as of now, there are some promising ideas in terms of looking at the ionosphere, but they're in their infancy. What may be a better thing to do is what actually I'm trying to do right now. Many folks who are listening to this will know that we successfully completed our second Kickstarter campaign earlier this year. We raised $120,000 to create the Disaster Prediction app. And that is going to do two things. One, it's going to be using those space weather phenomena we described earlier to warn of times when Earth is going to get more active. But also, we're going to be tracking the data that comes in on the GPS, the magnetometer, and on the EMF monitor within most of these cell phones. iPhones have all of those, and many Androids do as well. And so what we're going to be able to do is we're going to be able to see when there are multiple signals from different cell phones in a given area that are showing the same type of anomaly. Maybe there's 10 different cell phones in Los Angeles, and all of a sudden their GPS says they're in the Pacific Ocean. What are the chances that all 10 got catapulted 1,000 miles west at the same time? Or perhaps there's a magnetic field disruption of a certain microtesla that's read by 20 cell phones in Seattle. What are the chances they're all standing next to the exact same microwave with the door open? There are things like this where you start to say, okay, we can use some of these signals because it's more than just the ionosphere. We've seen everything from animal behavior going wild to positive ion emission prior to earthquakes, but also radio frequencies emerging and sort of spiking in power. You've seen magnetic field disruptions as well, and you've seen GPS disruptions. Just about every phone has a GPS detector in it as well. So what we're hoping to do is not wait to install a bunch of very expensive machines all over the world that may have to be recalibrated if they get hit by lightning or something. We're going to actually have this app monitoring some of the electromagnetic conditions around the globe, around these areas, and hopefully there will be enough people with these things on their cell phones that will be able to get some concrete data and actually start to be able to predict locations. So looking at the different electromagnetic signals, and that really is the only way to do this. Electricity is the great snitch of the universe. She's going to tell us pretty much everything that's going to happen. We just have to learn how to listen the right way. In June this year, I'll be giving another talk, third year in a row, at the Electric Universe Conference in Phoenix. And this year, it's going to be a little less specific and a little bit more macro view of a lot of the things that are going on in the community and a lot of the paths forward that seem to be most promising. We have on the horizon a period of great change as some of our leaders will be looking to others to carry this torch forward as we look 20, 30 years down the line. And so what does the future of the electric universe look like? And hopefully I'll be able to convince everyone that it is a promising looking future from a vastly interdisciplinary field of view, talking about a very broad range of disciplines, a very broad range of interests that are going to end up being advanced and coming around to really embrace some of the electric ideas that have been tossed around in the community the last few years.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.